We've been collecting data on our student performance and satisfaction, but how are we really doing? And how can that data give us insight into whether our materials, instructors, classroom environment, as well as our methodology or approach is effective? The job of a data scientist or a statistician is to discover the patterns in the data that might correlate to our effectiveness in those four factors. For example, for an individual student, a basic measure indicating how well they understood the material and mastered the required skills is their exam score. In a similar way, a statistician might interpret the effectiveness of our course by looking at the shape and pattern of all the student exam scores. The figure you see here is a graph of the frequency of each of the 501 of our most recent student exam scores. Do the scores cluster? Do they cluster in more than one group? Are there outliers? And what from our four factors could explain those clusters and outliers? One of the steps to uncovering patterns in social data like exam scores is to calculate the average score. Even at a practical level, this makes sense. Growing up in school, you knew that as an individual, if you did better than the average group score, you're probably doing okay. But when you are looking for patterns of how the group and subgroups may be scoring, you aren't just looking at how one individual compared to the average, but how the shape of the group, clusters or outliers, compared to the average. Average score is an example of central tendency, or how closely the group score clusters around a central value. Two other measures that are similar are the mode, which is the most frequent score, and the median, which, if you lined up all our students by their score, the median would be the score of the person exactly in the middle of the line. Another aspect a statistician would look at is how the scores spread out from the mean, median, or mode. One way to measure this spread is the standard deviation calculation, otherwise known as the calculation of the average deviation from the mean. Standard deviation is a way to determine how uniformly the scores spread out in two directions from the mean, like an umbrella. The larger the number, the more open or spread apart the scores are from the mean. The smaller the average deviation, the closer together the numbers are clustering around the mean. From a pattern standpoint, a small average deviation might suggest that all those factors that we talked about before impact the students equally. On the other hand, a large deviation indicates that perhaps there were some subgroups for which our approach is not working. The goal of standard deviation is to create a grid that spreads out from the mean at a regular length, like how a football field is divided up from the 50-yard line. The standard deviation will tell us something about the population in the same way you can tell something about the game by where the opponents are relative to the 50-yard line. The standard deviation is calculated by lining up all the scores and finding how much each differs from the mean by taking the score and subtracting the mean. This will yield positive values for scores greater than the mean and negative values for scores smaller than the mean. But we want the relative distance from the mean so that when we add the differences up, the positive and negatives don't cancel each other out. We square the differences, we add them up, we divide by the number of test scores, which in this case is 501, and then we take the square root. And that will give us the average deviation from the mean, or the standard deviation. Another calculation that we can use to better pinpoint each of the test scores within these standard deviation chunks is the z-score. To calculate a z-score, you go back and take the individual difference of a particular score, and you divide that difference by the standard deviation. You can see the z-scores that we calculated for our test scores in the graph below. You can also see that we started to group up the data in a histogram way according to the standard deviation bucket that they fell into. This is another aspect that statisticians look at when they look at grouped data. They start to look at the shape. And when they think about the shape, one of the things that they consider is whether or not it's symmetrical or asymmetrical. Mathematicians have developed several models for data distributions that appear to be symmetrical shape that help predict where new scores might fall. One such distribution model is the normal distribution. Social scientists call it the bell curve, and physicists call it the Gaussian curve. These curves, they only have one peak, and this peak is equal to the mean, mode, and median. By that we mean all three are the same number or the same value in a normal distribution. One benefit of using a normal distribution is that the standard deviation calculations are already worked out, so that it's known ahead of time that 68% of all scores will fall within one standard deviation, 95% within two, and 99.7% within three standard deviations. When we used SPSS to apply a normal distribution to our data, you can see that because the mode, or most frequent score, does not equal the mean, the distribution does not fit easily under a normal distribution curve. The histogram in this case is built using distribution groups of 5 percentage points. A final word about distribution shapes that are asymmetrical. Shapes can skew or pitch in a negative or positive direction. You will see that SPSS calculated the shape of our exam score distribution to be slightly negative or a negative skew. You can see this by the extended tail to the left of the normal distribution curve. One way that statisticians can use this information is that it may suggest whether or not a test was too hard, or a course was too hard, or a test was too easy, or a course was too easy, depending on how the distribution is skewed. There are many things hiding in the data we collect that can tell us how to be more effective, but it takes data science and statisticians to help us uncover those patterns.